Food has a history. Some people would say it even has a cosmogenealogy, the idea that we're actually related to it. But regardless, food is the common heritage of humanity. It was here before you, it was here before me. We didn't invent these tomatoes and carrots, but we depend on them nonetheless. The prophet Isaiah said, "All flesh is grass." And indeed, a great deal of our food starts out as a seed. Seed is the beginning and the end of much of our food, and it turns out that seeds may be a key to controlling it. The field I'm in is plant breeding. And in plant breeding, I need to cross my seeds with another seeds in order to improve the strain. We try to create new strains that farmers and gardeners can grow and that consumers can ultimately eat. This crossing depends on my ability to share my seeds with somebody else. This idea we call germplasm exchange. Germplasm exchange, or the ability to share each other's seeds to improve the strains, is an absolutely foundational aspect of my field. Without it, we would not be able to improve crops, and we would not be able to feed a growing public. Now, this idea of exchanging seeds, plant breeders call freedom to operate. In the last 30 years, the freedom to operate in my field has shrunk dramatically. It is now very difficult to exchange seeds with each other to improve crops. Now, it's fair to say that there are many seeds that are still publicly available in the public domain. And here's an example of 3 wheat varieties produced in Kansas. These varieties were produced by people in the public sector, and they're available to grow for any farmer or gardener. Any plant breeder could use them. Anybody could save the seeds of them. They are firmly in the public domain. But for every variety like this, there is at least 1, if not 10 varieties that are controlled through patents. This is an example of some patented strawberry varieties that come from the University of California, Davis, that you are very likely to eat come this spring or summer. These patented varieties are excellent. Farmers want to grow them, gardeners want to grow them, consumers want to eat them, but they are patented and controlled such that their genes and their seeds are unavailable for anybody to use to improve the strawberry. Now, this may be new information for you. You may not be aware that your food is patented in this way. But in fact, since 1980, a landmark Supreme Court case made it possible for people to patent seeds. And those patents have proliferated tremendously around the world. In fact, they've proliferated to a point where they are now commonplace. And I want to say a word about patents that is important not only to, I think, to the economy, because I think patents are a critical part of our system to promote innovation and research and development, but an important part of my family as well. This is a picture of my grandfather, Isidore, who has his hands crossed in the front of this group of men standing in front of the cigar factory where he worked. He was an immigrant to Chicago. He came to this country in 1900. And with his future brother-in-law, they started a laundry. And one of the first things they did in that laundry was invented a barber coat. And I don't know if you can see the barber coat in this patent picture, but they invented a hygienic barber coat that didn't collect hair in the pockets, and they sought to patent that. They attained a US patent. And I mention this because this tells the story of what patents can do. They are a way to capture and protect technology that people develop and create a small monopoly so that one can recoup the costs of their investment and be able to innovate and move it into the marketplace. Patents are important for our economy, and they were important to my family as well. I'd love to tell you that this barber coat patent was the foundation of the Goldman family fortune. That is not the case, however. And I'm sure that this barber coat was never actually manufactured. But the point is that patents are important, and there's something that I think are needed. But when it comes to food, the situation is a bit different. Nevertheless, in the last 30 years, thousands of patents on plant varieties have been issued. And this continues at a very rapid rate. Significant litigation in the United States and in other parts of the world has generally upheld this patenting system for crop varieties. And I would say that they underpin a very significant source of support of research and development in the seed sector. You might say, okay, not a big deal. Patents are fine on our food because they expire eventually. Patents might last 20 years, but the existence of a patent on our food has a chilling effect. And I want to describe to you what that means for me as a plant breeder when I find out that some of our seeds and some of our crops are patented. This is an example of a patent on a carrot. I'm a carrot breeder, and I want to breed carrots here in Wisconsin for Wisconsin farmers to grow and Wisconsin consumers to eat. This patent covers the pigment lycopene in carrot. Lycopene confers a red color to the root, and red carrots have existed for centuries, if not millennia. They're extremely important in Asia, where they are used for a New Year's ceremony. Nevertheless, if I'm breeding carrot here in Wisconsin and I breed redness into the carrot, I have to be careful not to infringe on this patent because the redness in carrot is now owned by this company. Likewise, purpleness in carrot has been patented. Carrots were originally purple when they were first domesticated. They were purple for thousands of years before they were orange. But with the right argument to the patent office and with the right kind of legal support, one can patent purpleness in carrot. And I, in Wisconsin, must be careful not to breed too purple a carrot that would infringe on this purpleness. This is why patents on food has a chilling effect. Today, farmers in Wisconsin will be buying seed for the 2020 growing season, and they will be buying bags of corn seed that look like this. This bag of corn seed has 32 patents in it. Now, those patents are important for the farmer. They protect the seed from pests and diseases. They also provide value for the seed grower and the company that produces the seed, and I don't want to disparage the scientific technology that went into these patents, but an important part of the patenting story is that these seeds are no longer available for anyone to use for any other purpose. A farmer can plant them once, nobody can save the seed, nobody can sell the seed, share the seed, trade the seed, or breed with the seed. And that is the net effect of controlling the intellectual property of seeds. Now, it's not just bags of corn seed. Here is a package of vegetable seed, and although you may not be able to read the fine print here, you are agreeing to a set of terms by cutting open this seed packet and taking the seeds out. This is very much like a software license that you click on as you accept those software licenses. I'm sure you read all of those as you're clicking on them. And the fine print on the seed packet says essentially the same thing, that by opening this packet, you're agreeing to a set of terms, that the genetics in here are owned by somebody else. You are not allowed to access those genetics for any purpose. You cannot cross these seeds with someone else's. You cannot save the seeds, share the seeds, sell the seeds, trade the seeds. This is another seed packet with even finer print. The bottom line on this one, you can't save the seed, you can't breed with the seed, and this one even prevents you from studying the seed. No research on these seeds is allowed. These kinds of so-called bag tags are a form of contract law that are appearing on seed packets around the world. And this means that we cannot share our seeds in the way we once did. It amounts to a siloization of the field of plant breeding to improve crops. When a farmer buys these seeds, they are essentially not owning them either. They are renting them from the company that owns them for the purposes of a one-time crop production. Can't breed with them, can't save them, can't trade them. And essentially, these materials are no longer part of the active germplasm pool among breeders. We are creating some very powerful silos. Another way to think of this is something I call the trajectory of the carrot. Carrots were domesticated in Afghanistan from Queen Anne's lace, a common weed. They were originally a purple-rooted vegetable. For thousands of years, they moved into Turkey and into Europe, finally into Northern Europe, where sometime in the 16th century, orange carrots appeared as a mutation. They were selected by the Dutch, and those orange carrots were brought to the United States by colonial settlers, where they became an important crop. I'm that little yellow dot at the bottom of that red line, but with the right kind of legal argument and enough resources, I can tie up the genes of carrot through a patent that were curated by centuries of my ancestors, farmers, gardeners, breeders, who were curating those genes for such a long period of time, but I can prevent you from using them if I obtain intellectual property control. So it is partly for this reason and all of this new control over seeds that I and a group of plant breeders and gardeners and farmers and citizens created an organization called the Open Source Seed Initiative, or OSSI. OSSI is now a 501c3, a not-for-profit company based here in Wisconsin, although it works across the United States, and it is served by an all-volunteer board. This idea for OSSI came from open source software. Many of you are familiar with open source software, and probably many of you use it. Products like Firefox, a common browser, open source. They support open exchange and tinkering. If you take the software code and you make a modification of it, it remains open source. This is a very important component of this idea that any modifications, any derivatives you produce remain in the open source commons. Another important idea about open source software and open source technology is that you can't prevent others from using it. And we saw this as an excellent model for what we could potentially do with seeds. That is, any crosses you make, any progeny you generate, remain in the open source pool for anybody to use. And so that's when we created the open source framework. The way that the seeds are distributed, the vehicle for distribution, is called the OSSI Pledge, and I'll read it for you. It says, you have the freedom to use these seeds in any way you choose, and in return, you pledge not to restrict others' use of the seeds or their derivatives by patents, licenses, or other means, and to include the pledge with any transfer of these seeds. So as these seeds are making their way out into the world, by opening the seed packet, it is this to which you are agreeing, and these seeds and their derivatives must be freely shared. The Open Source Seed Initiative started nearly 6 years ago. Seed has been, thousands of seed packets have been sent out all around the world, where varieties have now been developed and are being used in farmers' fields. One of the ways you could think about open source seeds is this analogy. It is similar to a conservation easement. We all agree as a society that there are certain plots of land that we wish to set aside in perpetuity for the good of society. It might cost money to do this, there might be regulations around it, but we agree that there is value, there's a communal value in setting aside this land. Similarly, we agree that there is value in setting aside a pool of seeds that will remain open and in the public domain. Another analogy that I like to use is a national park. A national park is a place that we all agree should be able to be visited by anybody, but you can't build your house on it. You can charge an admission fee, but it remains open in perpetuity. This is an important distinction about seeds because many people understand the idea of a commons. A commons is valuable. It means anybody can get access to it. But it turns out that our public domain seeds can be accessed and then with the right arguments patented and otherwise controlled. So that is why the OSSI project sought to create a protected commons. And the key word is protected. It means that everybody can have free access to that commons, but everybody is protected from restrictive use of what gets extracted from that commons. And that's what makes it a system that will hopefully have sustainability. How does it work? Well, anytime you would go and look for a seeds to plant in your garden, you go to a seed catalog or a website. This happens to be the High Mowing Seed Company in Vermont. You'll see a variety. This one happens to be Midnight Lightning Zucchini. And you'll notice that it has the open source logo down at the bottom. If you bought that packet of seed, it would have the pledge on it, and you would understand that the seed that you're buying can be used any way you wish. Aussie has grown in 6 years. Today, it has over 35 plant breeders contributing over 500 varieties of more than 50 crops, and those are fruits and flowers and ornamentals, vegetables. They are distributed all around the world. Many farmers and gardeners are using these seeds in their fields, and many plant breeders are using them as well. The seed system that we have today that produces the bulk of the food in this world is global. And recent data suggest that several companies, I'm talking about a handful of companies, 3 or 4 major companies own something like 2/3 of the world's crop seeds. This is likely to continue, and this is likely to expand in future years. The public domain, this is shrinking. The public plant breeding programs like mine are shrinking as the global seed industry further consolidates and controls the world's crop genetic resources. Now, I don't believe for a minute that an initiative like Aussie can ever supplant this global seed system. But in its own small way, I think it can contribute to increasing diversity in the seed system. And increasing diversity in the seed system is good. This is one of the ways that we can hedge our bets. And if we're going to have a chance of producing enough food for what was going to be 10 billion people within the next 30 years by 2050, we're going to have diversity in the seed system. Now, if the last 30 years is a guide, the crop varieties that are being developed today are going to become more and more protected, more and more controlled, more patented, and more unshared going forward. But it's one of my hopes that this pool of open crop genetic resources can grow, and that this pool of crop genetic resources can ultimately overflow its banks and become a global public resource for the future of humanity. As I said at the beginning, food has a future. Let's make sure that it also has a future that can feed the population of 10 billion people by 2050. Thank you.